All right, so we're going to start by graphing some functions. And this is important for many of you. I'm sure you've graphed functions before in previous math classes. And I'm going to guess many of you also then got used to graphing just using a graphing calculator or Desmos or some online resource at some point to just sketch functions and didn't have to sketch them by hand. And the reason we need to understand this is when you get to calculus, there will be some functions that you will be expected to know how to sketch without a calculator. Most of the classes most of your calculus classes in person anyhow will not let you use a calculator on an exam. So you have to have some knowledge of some functions. And so I'm going to introduce you or reintroduce you to some functions that you've probably studied before. And then we'll get into the idea of functions and how they can get transformed and reflected across axes. So let me start with my favorite graph to start with to introduce this is y equals the square root of x, or f of x, which is a fancy name for y, equals the square root of x. And many of you are probably familiar with this idea of a base graph or a parent graph. In other words, this is the simplest square root function, just y equals the square root of x, and then we're going to do some transformations with that graph. So this is our base graph. Over here, I do have a computer drawn graph here, but the smallest number you can take the square root of is 0, so it passes through the origin, 0, 0. We've got some points here. We've got 1, 1, because the square root of 1 is, let me write my equation here. If x is 1, the square root of 1 is 1. Another nice number to plug in is 4, because if I plug in 4, I get 2. And yeah, I have 9 is the next nice number, and the square root of 9 is 3. So it connects all these points. And in fact, some of you may know this as well. The square root of x graph is actually half of a sideways parabola, which is a graph we haven't talked about, but I'm sure many of you are familiar with that. All right, so this is our parent graph. And now what we're going to do is look at some transformations of that graph. So we'll keep referring to that one here. So if we were asked to graph y equals f of x plus 2, for us, our function is the square root of x. This would be the equivalent to y equals the square root of x plus 2. And many of you probably have gone over this before, where you know that when there's a plus 2 hanging out here at the end of our base graph, that it transforms the graph. It moves it up or down or left or right. And rather than resorting to just guessing, we can figure this out. If we plug in the smallest number we're allowed to take the square root of, which is 0, I'm going to get 0 plus 2. So I know instead of starting at 0, 0, which is where my normal square root graph starts, it starts at 0, 2. Okay. By the way, as we sketch these graphs, I said that you will be expected to know how to graph some of these functions in calculus. One nice thing, if you have to sketch something during a test, you don't have to draw the little hash marks and everything unless you want to. If you have graphing paper, that's great. But as long as you just make it look reasonable and kind of guesstimate where points are, that's usually fine. I'm not going to draw all the little hash marks in here for most of these. Okay, so we have 0, 2. The next nice number we saw to plug into the square root function is 1. That's going to give me 1, square root of 1. Plus 2 is 3. So I know my function is going to pass through 1, 3. If I plug in 4, that's going to be 2 plus 2 is going to be 4 as well. So it's going to pass through 4. Like if this is 1, 4 might be like maybe right here. 4, 2. And we start to see what this graph is doing. If we take a look at these points and we compare 4, 4. Sorry, this was 4, 4. If we look back at our base graph, we have the same x values, but what's happening is my y values, instead of going through 4, 2, it's going through 4, 4. Instead of going through 1, 1, it's going through 1, 3. And so what's happening to this graph is it has all of the same y values here. Maybe I'll put the other one, my base graph, in red here. Here is just y equals root x. Remember that passed through 1, 1, 4, 2, 0, 0. So essentially what's happening is my y values, it's the same graph, just I'm adding 2 to my y values, right? This is my function. This is y equals square root of x plus 2. And so what we learn from this is by adding a number at the end of a function, if I have an f of x and then I add or subtract, this has the effect of raising my function up or down. We call this a vertical shift. Up 2. It moved my base graph up 2 units. All right, so that can help us, because if we know this base graph and we see this again, we know it's just going to look like this 2 units up, and we could just get a rough sketch of that. Okay. All right, what about y equals f parentheses x plus 2? So now my plus 2 is inside with the x. So as an equation, this would look like this. My function is square root of x. If it's f of x plus 2, then I'm putting that in for x. So my equation is y equals the square root of x plus 2. What does that graph look like? Well, the 2 is not outside the function, it's inside. So it's not going to be a vertical shift. Well, let's see what happens. One way we can think about this is to think about what's the smallest number we're allowed to plug in for x. Remember, the smallest number we can take the square root of is 0. So what would go in for x to make this 0? It's going to be -2. So if I plug in -2 for x, I'm going to get 0. So this function starts at -2, 0. That's the smallest number I can plug in. All right. And then if I start plugging in some other values, if I plugged in -1, -1 plus 2 would give me 1. The square root of 1 is 1. So this is passing through -1, 1. And let me get my base graph up here again, because we'll see what's happening with this. Remember, my base graph is 0, 0, 1, 1. Here's regular square root of x. And we can start to see what's happening is instead of starting at 0, 0, it starts at -2, 0. And my next point, 1, x is 1, y is 1. Well, now it's -1, y is 1. So what's happening is it's moving all of my points from my base graph to the left by 2 units. So I'm just going to, we can certainly find some other points, but that's just my base graph shifted to the left by 2 units. And so that's always going to be true in general as well. Now, this one you got to be careful about, because a lot of people, when they see x plus 2, many people think plus 2 means it's going to move to the right because the positive numbers are over here. But it's opposite when the graph shifts left and right. This is actually called a horizontal shift. And this graph is moving left 2. Left 2. If I wanted to move it to the right by 2, this should have been y equals the square root of x minus 2. Maybe I'll write that down. Or let's say I had y equals the square root of x minus 5. That would be my base graph shifted to the right by 5 units. Okay, so this is just an extra example. So we've got vertical shift, horizontal shift. Other things that can happen to your base graph, we could look at y equals 2 times f of x. So for us, that would be 2 times the square root of x. Let's see what's happening here. I guess I should have done this ahead of time, but let's put in our base graph. I'm just estimating. So here's y equals the square root of x. Remember how it goes through 0, 0, 1, 1. 4, 2, there's other points there. Well, let's see what happens. If I plug in 0 for x, square root of 0 is 0 times 2 is still 0. So it is starting at the origin. There's no shifting left or right here. If I plug in 1, however, now I get 1 and then I times it by 2. So that gives me 1, 2. If I plug in 4, square root of 4 is 2. 2 times 2 is 4. So instead of going through 4, 2, it's going through 4, 4. And we can start to see what's happening here is the y values that I was getting for just the square root of x are now getting doubled, right? I'm taking whatever y value I got out of my parent graph, my base graph, and I'm now multiplying it by 2. So, whoops, this is 2 root x. So this is true in general now. If you have a number in front of your function like 2, that is going to stretch. We call this a vertical stretch. It's going to pull your y values, in this case, double them. Okay. Vertical stretch. And I'll put in parentheses. In other words, this is doubling, double your y values. Okay, yeah, good enough. Okay, what about, here's another situation. What if I put the 2 inside? What if it's y equals the square root of 2x? What is that going to do? All right, well, let's see. Once again, need my base graph. Well, let's see. If I plug in 0, still get 0 because the square root of 0 is 0. But now maybe the way to think about this is, what's the next nice number to plug in to take the square root of is, you want the next nice number besides 0 is 1, right? The next nice square root. Well, what would have to go in for x to make this inside equal to 1? Can you see that it would have to be 1/2, huh? 2 times a half would be 1, and then the square root of 1 is 1. So that means instead of going through 1, 1, it's going to go through 1/2, 1. I'm going to label that out here. 1/2, 1 is this point. In order for this to come out to be 4, x is going to have to be 2, in which case I would get 4, and the square root of 4 is 2. So essentially, instead of 4, 2, now I'm going to have 2, 2. Okay, and what we see, full graph would look something like this. It's a little hard to see. It looks like it's vertically higher than that, but what's really happening, if you see, is the x values, all my x values on this graph are getting halved, right? Instead of 4, 2, it's 2, 2. Instead of 1, 1, it's 1/2, 1. And we call that a horizontal compression. The graph is being compressed. The x values are being compressed horizontally. So if you're, and this is true for vertical stretches or compressions too. If you're making something bigger, we call it a stretch. If you're compressing it, we call it a compression rather than a stretch, okay? Because you're shrinking your x values. There you go. X values halved. Okay. At this point, I want to make a comment here. I want you to notice something that I find really useful when I'm thinking about graphing functions and how to not resort to memorization, okay? For one thing, notice, and we can go back to the previous examples, when my 2 was outside my function, 2 root x, notice that affected my y values. Whereas when my 2 was inside with my x values, with the x, it was affecting my x values. And that was true if you go back to our shift, our other shift, when the 2 is outside here, that was a vertical shift. When the 2 was within the function, that was a horizontal shift. The other thing I'd like to point out is, notice with the horizontal shifts, it's always the opposite of what you would think it would be, right? X plus 2 makes you think to the right. No, it's actually to the left. When you see a 2x inside with here, you would think it's going to double your x values, but in fact, it's halving your x values, right? So if you can keep that in mind, I find that that helps me. All right, 2 more, and then we'll go on to more complicated functions here. What if I just have y equals negative f of x, which is the equivalent of y equals negative root x? And let's do this one together. Whereas if I have f of negative x, that's the same thing as the square root of negative x. Based on what we just said, which do you think this first one right here, is this going to affect my x or my y values, given that this negative is outside the function? Hopefully you agree that it's going to change my y values. And how is it going to change it? Well, all of the normal y values I get out of square root of x, 1, 1, 4, 2, they're all going to become negative, aren't they? So instead of 1, 1, it's going to be 1, negative 1. And instead of 4, 2, it's going to be 4, negative 2. And so what was the net effect of putting this negative outside the function? We say that the graph gets reflected about the x-axis, right? Your y values are becoming negative. This is 1, negative 1. This is 4, negative 2. So this negative outside the function reflects the base graph about the x-axis. It's going to make your y values negative, right? Whereas this one, you probably already guessed it, this negative inside means it's going to reflect your graph around the y-axis. Reflects about the y-axis. And that's pretty easy to see if you think about plugging in points. Normally for your regular square root function, you're only allowed to plug in positive x values because you can only take the square root of positive numbers. But on this graph, in order for this to be positive, you need to plug in negative x values for x because they're going to get multiplied by a negative. So instead of passing through 1, 1, it's going to pass through negative 1, 1. 4, 2 is going to get reflected to negative 4, 2. And that's kind of it. These ideas of shifting the graph up or down, compressing them vertically, compressing or stretching vertically or horizontal, and then reflections about the x or y axis. These are the main transformations. So, and then of course, you know, we can put these together. So let's practice graphing something like this. Now that we know some stuff, we can view this function f of x equals the square root of x plus 9 minus 2. That plus 9, as we saw, is going to have the effect of moving my graph left 9, my parent graph, and the minus 2 is going to move my graph down 2. So if we think about our parent graph, and the easiest way, you know, if you get these parent graphs down, we're going to talk about some more going forward here, but if you can remember that square root function, that original square root function, which starts at the origin and bends off to the right, normally my parent graph would start right here, curve to the right, but every single point in this graph has been moved left 9, down 2. So my starting point is going to be, I'll just say it's about right here, negative 9, negative 2. And I know it's a square root graph, so it's going to be bending off. Before I sketch it though, what I maybe want to check out is, you know, is it going to intersect the x-axis here and the y-axis here, or is it going to curve and maybe intersect the x-axis at a positive value? So I might want to find some more points. And in fact, this is a good time to introduce, oh good, I have it in the directions. Let's find, the easy way to figure that out is let's find our x and y intercepts. The y-intercept is the easiest point to find because wherever your graph crosses the y-axis, x is equal to 0. So I'll put y-intercept set x equal to 0. And it's just going to be a point. So if I just let x be 0, it's pretty easy to calculate that. That's going to be the square root of 9, which is 3. 3 minus 2 is 1. My y-intercept is 0, 1. And actually, now that I know that, I can sketch the graph because I know it's got to look something like this, like our square root function. And I can see now that I have an X-intercept as well, and it's going to be some kind of a negative X value. So to find your X-intercept, remember when your graph crosses the X-axis, it's Y that's 0. Set Y equal to 0. Y is f of x. So if I said 0 equal to the square root of x plus 9 minus 2, okay, there's usually a little more work to find your X-intercept because you've got to solve for x. So I could add 2 over. I could square both sides to get rid of the square root. 4 equals x plus 9. So x would be negative 5. This point is negative 5, 0. Okay. Here's another one. I've got f of x equals negative square root of 1/2 x. Let's identify the transformations. We know the negative outside the function has the, remember that's going to affect your y values. That's going to reflect about the x-axis. I know that's a little weird when I say it affects the y values, so it's reflecting around the x-axis, but think about that. If your y values reflect around the x-axis, then your y values are getting changed, right? And then, okay, we saw that the 1/2 inside with the x, it's going to affect the x values. And remember that it's kind of it's the opposite of what you would think. You think you're going to half your x values, but in fact, it's going to double your x values. That's going to be a stretch in the horizontal way, right? Stretch. So I can pretty much see what the graph's going to look like if I know there's no shifting left or right. So it's still going to start at the origin. But instead of going up like a normal square root graph, it's reflected around the x-axis. It's going to go down. It's going to look like this. And you can always sketch that first. And then we can just put, to reflect the fact that the x values have been doubled, we can add some points there. For example, what would I have to plug in to get 1 here? I'd have to plug in 2. So maybe we'll put in 2, 1. In order for this to be 4, you're going to have to plug in 8 for x. So I would have 8, and then you would end up with, whoops, this is -1, and this should be -2. Okay, and a couple points is fine. You know, your origin is your x and your y-intercept, so we don't have any of those to find, but maybe add a couple of points, and that's all I really need, and that's all really any teacher would probably need at this level. So, all right, let's see how that compares to this one. F of x equals 1/2 square root of negative x. So now my 1/2 is affecting my y values. And with the y values, it is what you would think it is. It's going to half my y values. So this is going to be a compression, vertical compression. It's going to half my y values of my base graph, right? My normal base graph. And then we know the negative with the x is going to reflect about the y-axis. So sketching that, I know my normal square root function base graph goes this way. It's reflected about the x-axis. And I know that there's a vertical compression, so it's not going to be as steep. It's going to be kind of flat like this. And I can always pick some points here. So if I plugged in, for example, -1 for x, this would become 1. I would have -1, 1/2. If I plugged in -4 for x, that's going to become 2. Half of 2 is 2. Good enough. This last one is a little bit tricky. You know, if this had been the square root of x minus 4, that would simply be just a horizontal shift 4 units to the right. But it's backwards, right? It's 4 minus x, not x minus 4. When this happens, what you need to do, you want to think about it this way. If I factored out a negative from 4 minus x, that's going to become negative parentheses x minus 4. And the shifts now that we want to think, the transformations that have happened is this is just like the last one's going to cause a reflection of your X values, which is going to reflect around the Y axis. And this is going to move my graph to the right 4 units. So the way to think of this is, you know, your normal square root function, if I reflect it around the Y axis, is going to go this way, and then I'm going to move it 4 units. So it's going to start at 4, 0. And you can see that if you plug in 4, you're going to get 0. And it's going to move to the left, just like a square root of negative X graph. We could even find, so this time it has a Y-intercept, which is easy to find. If I plug in 0 for X, the square root of 4 is 2. So this is 0, 2. And then just a couple more examples here, just so we can see all of these things we've learned for different, these apply to all functions, not just the square root function. I just like that one to start with because it's, well, it's my favorite one. Okay, some of you may recognize this graph. We'll make it a little darker. It has the classic shape of a V, and this function is the absolute value of X, which is really made up of just 2 lines. We're going to talk about lines in coming up here. This line right here is just a portion of Y equals X, starting at 0 going off, and this is Y equals negative X. And that is a very popular graph. When you get to calculus, they expect you to know that graph. So here is one. What are my transformations? I have absolute value of X minus 3 and then minus 4 outside. So the minus 3 inside is going to affect my X values, not left 3. Remember, it's the opposite. This is going to move my graph right 3. And that's outside. It's going to move my graph down 4. And so the way I like to think of it is kind of the important point on the absolute value function is the bottom of that V, which normally starts at 0, 0. But now that point has been moved right 3 down 4. So it's going to be at 3, negative 4, maybe about right here. So I know my V is going to look something like this. Now, again, I might want to hold off on drawing this part because I need to see if it's, where does it hit the Y-axis? Is it up here? Is it down here? Is it at the origin? So let's find our Y-intercept. And remember, so another way to write that is you could say that's just plugging in 0 for X. So it's f of 0. That's the absolute value of 0 minus 3 minus 4. Absolute value of negative 3 is 3. 3 minus 4 is negative 1. So my Y-intercept is 0, negative 1. I also have 2 X-intercepts, which I could find. But I have to solve this equation. This is good practice. So if I move the 4 over, and the way I like to think about this is if I cover up what 2 numbers behind my finger would make that equation true. Hopefully you see that what's behind my finger could either be 4 or negative 4, right? Absolute value of 4 is 4. The absolute value of negative 4 is 4. So that means that either X minus 3 equals 4 or X minus 3 equals negative 4. This gives me 7. This gives me negative 1. So I know that this point is 7, 0. And this point right here is negative 1, 0. And then one more. Graphs did not come out very dark. So this graph right here, which I'm darkening up here, has a familiar shape maybe for many of you. This is the graph of, I'll write it right here, f of x equals x cubed. x cubed. That's your cubic function. It has this little bend in it right at the origin. It does actually get flat, and then it goes up very steeply. And this is hard to see, but this was supposed to be 1 minus parentheses x minus 2 whole thing cubed. And sometimes you have to rearrange it a little bit to see the transformation. So I'm just going to simply rewrite this as negative quantity x minus 2 cubed, and then put the plus 1 at the end. So we can see there's a lot going on here. This negative is outside my function, so that's going to reflect about the x-axis. The minus 2 inside with my cubed is going to move my graph right 2, and the plus 1 at the very end is going to move my graph up 1. Before we sketch this, since I've got x cubed here, let's think about what the graph of y equals negative x cubed would look like. I'll do that in red here. And remember, that's when I say reflect about the x-axis, this part comes down, but then this part actually goes up. So that graph's going to look something like this. This red one here would be y equals negative x cubed. That would be an x cubed graph reflected over the x-axis. So that's what we have going on here. It's going to look like this red graph, but then it's going to get shifted over 2 and up 1. Over 2, up 1. Let's call this 2, 1. And that's where my flat part is, right? Like the x cubed graph is going to get flat right here, and then keep going down and keep going up this way. And so to finish this off, let's find our Y-intercept and our X-intercept. You don't have to show me work on the Y-intercept, because I hope you can just do it in your head. You're just plugging in 0 for x. And if you plug in 0 for x, you're going to end up with negative 2 cubed is negative 8, and you're going to end up with 1 minus negative 8, which is actually positive 9. X-intercepts, though, usually require a little more work, so probably want to do that work. I'll do that over here. That's setting your function equal to 0. To solve this, I can move this x minus 2 cubed over to the left side. To undo a cube, I can take the cube root of both sides. And fortunately, the cube root of 1 is still 1, so I get an x-intercept of 3. Okay. All right, so I'll stop here. Take a look at the problem set. You have similar types of problems. There will be some parabolas on there, so there's going to be another video about how to graph parabolas coming up, so look for that.